Hi, welcome back. Third example of applications of derivatives regarding functions and trying to find their pattern of increase and decrease. Like I said before in my past video and in the first video, right now at this stage we're not particularly paying attention or worrying about the graph of the function per se, okay? As you saw in the past video, I just made a quick sketch to have an idea of how the function decreased at all times, okay? And in the first video, I drew a quick sketch of how the function first increased and then decreased, okay? But we're not really paying attention to that yet, okay? We will get there in further videos, but right now, I want you to get the practice of finding the problematic points and evaluating the random points in those intervals to see if the function increases or not, okay? So here's our third example. It's a little bit more expressive, as I can say. We have y equals x thirds minus cubic root of x, okay? So first thing we do, we find y prime, and in this case, y prime is going to look like this. Again, I'm going to solve it right here on the right side real quick, and then I erase it. Y prime is going to be derivative of x thirds is going to be 1/3. Okay, derivative of x is 1, and 1 times 1/3 is 1/3. Minus, and what am I going to do with the cubic root? Remember what we learned in our video about derivative with radicals? Remember? If not, please click on the description, and I'm going to post a link on it so you can see it right away, okay? We're going to always visualize radicals as exponents, meaning that we're going to have x powered to 1/3, okay? Cubic root of x is the same thing as me writing x powered to 1/3. Again, for a further explanation, click on the description and go to the derivative of radicals, okay? So, since we have this, derivative of this is going to be, using the exponents rule, using k, x, n prime rule, we're going to obtain 1/3 goes down, multiplying x, and 1/3 minus 1 is 1/3 minus 3/3, and that's minus 2/3. Minus 2/3, right? Yeah. And there we go. Now erase this. And this is my y prime, which I'm going to write on the left side. 1/3 minus 1/3 multiplies x powered to minus 2/3. Okay? And I'm going to erase this. Now we have to find the problematic points. Okay? Where y prime is 0. Okay? So we make y prime equal to 0. And we're going to have 1/3 minus 1/3 of x powered to 2/3. Okay? And now we can rewrite this to make it look a little bit, nicer, so that we can rearrange the whole equation, okay? So let me solve it real quick on this side of the board, and then I'll erase it, okay? And I'll get the result right here, okay? So let me divide this. In solving this, we're going to have 1/3 equal 1/3 cube root of x squared. Okay, I just rewrote this as a radical so I can see it better. Okay, so what cancels here? What can be canceled right here? Well, first of all, I have a problem point which is x equals 0, okay? A problem point is anything that either makes y prime equals 0 or that brings an issue to y prime. And well, in this case, if x equals 0, there is an issue with y prime. So we're going to make a note on that point, okay? So one point is going to be x1 equals 0. That's our first one. So if x is not 0, and we make that annotation over there, the 3 simplifies, they cancel each other, and then this goes all the way up, and we're going to end up with cubic root of x squared equal 1. And now I have to leave the x alone to find the other 2 points, right? Or whatever points. So if I make this cube, to cancel the root, I'm going to end up with cube on left and cube on right. Cube of cube root, they cancel each other. So I end up with x squared equals 1 cube. But 1 cube is 1. 1 cube of 1 is 1. And then, to simplify the x, I do square root, left and right. And square root of square is x, and square root of 1 is plus and minus 1. Remember that the square root of a positive number is always going to give you 2 numbers, okay? Positive and negative. The square root of 4 is 2 and minus 2. The square root of 9 is 3 and minus 3. Square root of 16 is 4 and minus 4. Square root of 1 is 1 and minus 1. Why is that? Because if you do the opposite, if you do square of 1, you get 1. But if you do the square of minus 1, you also get 1. So you have to consider both points, okay? So we have x1 equals 0 marked, x2 equals minus 1, and x3 equals 1. We have 3 points, okay? So how many intervals are we going to have? We have 3 points. We're going to have 4 intervals, okay? Going to erase this. Take a quick look at it. Just kidding. Okay, going to erase it. There we go. Now, the intervals are, remember that the intervals are going to be arranged in order, okay? From the most negative to the most positive. And we're going to have minus infinite to, well, the first point that we have would be minus 1. The second one is going to be minus 1 to 0. The third one is going to be 0 to 1. And then fourth one is going to be 1 to positive infinite. Okay, we have 3 points, we have 4 intervals. Okay, 3 divisions of the real x-axis. Okay, first one, minus infinite, minus 1. Second one is 1, 0. Third one, 0, 1. And fourth one, 1, positive infinite. So now that we have y prime here, all we have to do is evaluate, pick a random value on each interval and see what happens to the sign of y prime. If it's positive, the function is increasing. If it's negative, the function is decreasing, okay? So, since y prime is 1/3 of minus 1/3 cubic root of x squared, and now I'm writing it this way because it's easier to evaluate this way, okay? It's more comfortable. Let's pick a random value from the first interval, okay? Give me 1. And please don't pick minus 2.567 because it doesn't make any sense. Just pick an easy one, okay? Minus 2. Minus 2 belongs to this interval. So, minus 2. Minus 2 squared is 4. Square root of 4? Cubic root of 4? That's going to be complicated. Let's do... Well, I'll stick with 4. It's okay. Cubic root of 4. Let me get my calculator. I'm not that good with cubic roots. Okay, cubic root of 4 is approximately 1.5 times 3, 4.7. So we're going to have 1 over 4.7 is going to be 0.21, and this is going to be minus 1/3, which is 0.33 minus 0.21. So the value of it is positive, okay? So this means that in this interval, the function is increasing, okay? Let's pick a random value within this interval, okay? Minus 1, 0, well, we're going to have quite an issue here. Let's pick minus 1/2. That's the one that kind of makes sense, okay? So let's see, minus 1/2 squared is minus 1/4. Cubic root of that, well, that's going to be a real complicated one. 0.25 square root, 0.62 times 3, 1 over 1.88, 0.53, and that is going to be negative. Okay, let's pick a random value between 0 and 1, 1/2. It's probably going to be the same, only that it's going to be negative. Let me verify. Yeah, because this is going to be positive. 1 square of 1/2 is 1/4. Cubic is the same. This is the same. Yeah, it's negative. And then let's pick a random value inside this. Let's say x equals 9. Okay, 9 squared is 81. Cubic root of 81 is 4.3 times this minus this. This whole square is going to be negative, therefore positive, sorry, therefore this is going to be positive. So again, this is the result. After evaluating, this is how the function grows in these 4 intervals. And notice something very interesting. Even though we had 4 intervals right here, 1, 2, 3, 4, these two didn't have any change on the function. So there's probably just a minor thing happening with 0. And we will probably see that in a further video. Other than that, the function grows between minus infinite and minus 1. It decreases between minus 1 and 1. And then it grows again between 1 and infinite. Okay? The graph, like I said, for now I'm not going to worry about it. We will get to that in a further video. Right now we're just practicing application of derivatives to find how the function increases or decreases. Okay? See you in the next video.